Okay, so the question is, when should you use vertical rectangles or horizontal rectangles? And some of your homework examples will say find the Rx region or tell you specifically that, and some will say use the RY region. But if they don't, if they just give you two functions and say find the area, then you have an option. Now let's look over here to the left first of all. We can see we have red, we have black, and then we have this x-axis, which I just put in purple to distinguish the difference. But we can see that if I drew a dx rectangle in here, it has an upper boundary that's red and a lower boundary that's purple, but that's only up to this part of the shape, right? Of the figure, because if I just threw one over here, a representative dx, my upper is red, but my lower is black. So I would have to have two regions here, just like we did the last time, a region A and a region, a area 1 and an area 2, and add them together. So that would be like probably a little more work. Now, let's look at that same exact figure, but be willing to put a horizontal rectangle in and ask ourselves, now when we're doing our Y region, we have our rightmost minus our leftmost, which that gives us all the same no matter where I would put my rectangle, right? My rightmost would be black and my leftmost would be red, so it's just going to be one evaluation. So we could see in this case, if I'm given the option, this is probably the one that's a little bit less work. Not that you should still get the same answer doing all the correct math for it, but that's a little bit of an idea of how you understand which region to choose or which rectangles you may want to use. And I had some real good questions in class about this. Now remember, if we choose to do an RY region, that we want to make a note and solve these for x equals, and this one as well, so that way when we write our function, everything will be in terms of the variable y. Solve for x. The other thing when we're dealing with an RY region is that our boundaries are going to be in respect to the y-axis. So just in our formulas we had C and D. So just a couple of things to recall when you're working with RY. Okay, so I just copied this. We're going to actually solve this using an RY region. So I want you to attempt some of the stuff I just told you. Rewrite this. Make sure you solve these for x equals. Solve this for x equals. It may help to algebraically solve for the intersections. So I want you to try a few of those things and then we'll check our work. Okay, so let me move this out the way. So first thing we did was solve this for x equals, and we got y squared. Actually, I'm missing that x equals y squared. Okay, and then we solved this one for x equals, so we have in terms of x. The next thing is we worked on this intersection here. It was not so nice. I actually messed up and wrote the problem down wrong, so we ended up with one that didn't factor very well, so that's not going to happen very often, but we just went ahead and made sure and set up how we would solve this, and we're going to, as one of the students said, stop while we're ahead and not go much further with this to actually calculate it, but just to represent it. So we're going to move on to the next example because we're getting short on time. Okay, here's our next example. We want to do an RY region on this, so go ahead and try to set that up. Solve these for x equals. X equals, this is going to be our green line. This is our purple line, so you want to sketch all those graphs. Remember, the graphs won't be provided for you. You can solve those. Also, your calculator will do intersection points for you as well, which is fine. So go ahead and set up all those, and then we're going to work on our area. Okay, solve this from x equals. Solve this one for x equals. We drew our rectangle in, it's dy. So remember our intervals are on our y-axis, so from -1 to +2. So that's going to be our um, intervals and our boundaries right there. The rightmost, because this is an RY region, the rightmost is this blue, which is y plus 4, minus the leftmost, which is going to be this red one, um, dy. So go ahead and set this up. The next thing you want to do is algebraically simplify this, and then we'll evaluate. Okay, so we find our antiderivative, and then we use fundamental theorem of calculus to solve this. Evaluate first one at 2, second one at -1, algebraically simplify those, and the area of the shaded region is going to be 16.5 units square. So pause it and check your work on that if you need to. And then this is your next example. So write it down, try to get the sketch of it. I made a few notes right here. So it's above the x-axis, which means greater than or equal to 0 on the interval from -2 to 0, right here, because we're going to be doing our dx rectangles. So we're going to have two different regions, right? So we'll have this one with yellow, and then we'll have one that's just over here. We can pick anywhere to put these representative rectangles. It just helps us to know um, our upper and lower. So the other thing, we also need to know where they change. So that's at -2, 0, and 1, 2, 3. Okay, so sketch that, and then we're going to work on this next one. Okay, so if we were to write this first one, if we wrote it all as one area, added the yellow plus the blue, the first one goes from -2 to 0. That's here to here. The upper function, upper boundary, is the red minus the y equals 0. So that's going to be this one minus the red, dx, plus for the area of this one, it's going to be from 0 to 3. So we put 0 to 3. And this is the upper boundary of this rectangle, right? So it would be 0 minus the red this time, which is represented like that. So we're going to evaluate this one, and at the very end, just add our areas together. Okay, so when this is evaluated, remember you'll evaluate it at 0 first, which will just give you 0, and then evaluate it everywhere there's an x, plug in a -2, and simplify. You should get 16/3 for this one on the right. Evaluate all the x's to be 3, and then the next time 0, which that's the easy one, and then add these two together, and you should finish with approximately 21.08 units square. Okay, and for this next part, this is printed out completely on your PDF if you have it, but it's to set up the sum of integrals that can be used to find the area. First of all, they just tell us to do with respect to x, and the next time with respect to y, and I want you to see that it's just between this page and this page, it's the same exact image. So this one I made dx rectangles, the vertical rectangles, and labeled everything with that. And then this is the same exact image, but I just solved everything when I'm dealing with an RY region. Okay, I made horizontal rectangles. I recalled that it's my right versus my left. You know, my right subtract my left. And I wrote down some quick reminders here when you're determining your intervals. Also remember for the RY region, you have to solve your equations for x equals, for x equals, for x equals. So that way when you write it, we have all the same variable. So on these next two examples, I already have it all worked out for you. It just says to represent the area. I want you to look at that for a few minutes, and then I'll see if you have any questions. Alright, we drew two rectangles because this one, the upper is red and the lower is blue, and that occurs on the interval from 0 to 1, so that's this case. So 0 to 1, the red minus the blue, Then for this other rectangle over here, the upper boundary is purple, and then this one's blue, and that occurs from 1 to 2. So 1 to 2, and then we did purple minus the blue. So that would be that case. Okay, remember we've solved everything for x equals, x equals, x equals. For this rectangle, from if I drew a dashed line from here and colored it a different region, the right is blue and the left is red. So from 0 to 2, because that's the y value, 0 to 2, the right, so I need to say blue minus red. Blue is y minus red, which is 1/3 y right here. Okay, good. So then from this point up, the right side is purple and the left side is red. So I need to do purple minus red, and that's from 2 to 3, because remember we're working with the y values there. So from 2 to 3, I say purple, it's purple, minus the red dy. So just take your time and make sure you look at your rectangles and say you need to do the rightmost minus the leftmost when you're working with the RY region, and just be focused when you work on this.